Hello friends, welcome to Susan and John MathTube. This is lesson number 2 in the examination preparation series for the second year engineering students. And we continue our discussion based on line integrals. And in this video, we will learn a lot of questions from your past paper question papers. And as always, before we start, how to use the video lessons effectively. So point number 1, okay, are you ready with the pen and a paper? And point number 2, make sure you work out all the problems till the end. And the third one, if you have any confusion, just watch that part again and again till your concepts are crystal clear. And the fourth one, once you complete watching this video, work out a lot of problems of the same type from any book you like, and finally you try to work out the questions from your past year question papers, and if you're able to do it by yourself, then congrats, you use the video lessons effectively. Okay, so let's start with the topic. Okay, I have a question from 2074. Okay, now they're asking, find the total work done. Now look at this. This video is a continuation of lesson 1. So if you have not watched lesson 1, you will find it hard to understand the things which you are discussing right now. So if you have not watched lesson 1, pause the video right now and watch lesson 1 and then start with lesson 2. Okay, so we want to find the total work done. And we learned that work done is nothing but integral over the required path, and here we have f dot dr. Okay, now you can see that there is only I and j, and the set coordinate is 0 in the path, so that means we are in 2 dimension. Okay, so the path is a circle, x square plus y square equal to a square. That is a circle. And I told you earlier, whenever you have a circle or ellipse or asteroid, the best method is convert it into parametric form. So the parametric form is x is equal to a cos t and y is equal to a sin t. Now look at this. This is our x-axis and y-axis. And once you have parametric form, we get all the points which will create the circle. For example, if you put t equal to 0, you're going to get a comma 0, and that point will be in the x-axis. Now you put 10 degree, 20 degree, 30 degree. Okay, for example, if you put 30 degree, it will become a into root 3 by 2 and a into 1 by 2. And when you put 90 degree, this becomes 0 comma a. So we get point, and finally 90 degree. Again, you keep on putting points, and when you put all the values between 0 and 2 pi, when you put all the values starting from 0 to 2 pi, you will complete one round. And that's the logic behind parametric form. Anyway, we need dx, and that will be minus a sin t dt, and dy, that will be a cos t dt. Now we have f here. You can focus. I'm not going to write that now. And as always, let r be xi plus yj plus, the set coordinate is 0. So xi plus yj. So dr is equal to dxi plus dyj. These are the basic steps. Now what we do is, what did we do in the last video? Yeah, f dot dr. So f dot dr. So you focus on f and dr, and that's going to give me sin y dx plus x into 1 plus cos y dy. This function is a little bit complicated than the functions we saw earlier. Anyway, we have our f dot dr. Now let's plug in all these values. That means the value of x, value of y, so that the whole thing will change into the parameter, that is t. And the curve will be incorporated into the integrand, that is f dot dr. So we know x is a cos t and y is a sin t, and the dx and dy, that is minus a sin t and a cos t dt. So let's plug in all those values. So we get sin a sin t, and dx is minus a sin t dt, plus what is x? A cos t, I'll put square brackets, 1 plus cos, what is y? A sin t, and dy is a cos t dt. Now let's simplify this. So this is equal to, it's a long expression. So I'll put that a here. Let's put minus a sin t, sin a sin t. Now it apply distributive property. Okay, this will also go inside. This will also come here. Or if you're confused, look at this. This is a cos t and we have a cos t. So total a square cos square t will go inside. And that is a square cos square t plus a square cos square t times cos a sin t. You will understand this only if you are using a pen and paper and you are working out the problem along with me. Yeah. Now the next step, I'm going to keep this and this together. So I have a reason to do that. So minus a sin t, sin a sin t, plus a square cos square t, cos a sin t, plus a square into, look at this, we have to do integration. And when you learn basic integration in class 11, you might have learned how to integrate cos square and sin square. And the answer is double angle. You just convert this like half into 1 plus cos 2t. You will be able to integrate cos square t. I'll repeat once more. In your basic integration, you learn how to integrate cos square and sin square. So to manipulate it using the trigonometric formula, 1 by 2 into 1 plus cos 2t. Okay, so we are ready with f dot dr. Now we are going to integrate. I'll start from this end. So integral over c f dot dr, that is our work done, is equal to integral t equal to 0 to 2 pi. We already found the value of t. It's a circle, so it varies from 0 to 2 pi. And our function. And the whole thing will be accompanied by dt, which I forgot to write earlier because dt comes common. Okay, now what we do is, we are going to write this as a differential because I can already see a product rule being applied here. Kind of like first function into derivative of second plus second function into derivative of first. That part is available here. So I'm going to take a outside, and then okay, I got it. So it's like sine a sine t. So this is the first function, and the derivative of cos is minus sine t. If you want in differential form, it's better to write minus sine t dt. Yeah, plus now what we do is, so we have first function and derivative of second, and now the second function, so that of course is cos t, that is why its derivative is here, and the derivative of the first, that means you have to differentiate this quantity, that will be cos a sine t times a cos t, plus for this part we will do the integration later. So t equal to 0 to 2 pi a square by 2 into 1 plus cos 2t dt. You have to understand this step. It's a very important step. It's based on differentials. Look at this. U v dash plus v u dash gives us the derivative of u into v. Let's say differentiated with respect to x. So this will be of course accompanied by dx if you want it in the differential format. So the first integral is going to be t equal to 0 to 2 pi, the differential of sine a sine t, and this is second function, into cos t. You can check it once more and don't forget this a. So look at this, first function and derivative of the second, or to be honest, the differential of the second, plus second function into the differential of the first. I hope you are able to see that. First function, differential of the second, and second function, differential of the first. And remember the property, integral of a differential of a function will be the function. So the first part is settled. Now we have to integrate the second part, and that's very easy. A square by 2 is a constant, and if you integrate 1 you get t, and the integral of cos is sine 2t by 2 within the limits 0 to 2 pi. Okay, so let's go for the next step. So this is equal to a times, I told you, integral and the differential. So you're going to get sine a sine t cos t within the limits t equal to 0 to 2 pi, plus a square by 2. Now we plug in the upper limit, that will be 2 pi, plus when you plug in it will be sine 4 pi, and 0 sine 0, so that is going to be 0. Now let's plug in 2 pi here. Okay, that's going to be 0, sine 0 is 0, 0 into something 0, plug in. Okay, so the first one is also 0, so we end up with a square by 2 into 2 pi, and that is equal to pi a square. That was a little bit complicated, so make sure you understand these two steps. Okay, let's move on to the next question. Okay, so this is a question they asked long back, 2071. Okay, so using the line integrals, compute the work done. Now, I told you in the last problem, work done is nothing but integral over c f dot dr, isn't it? So we are asked to find integral over c f dot dr. And another interesting thing, z equal to 0. That means we are in 2 dimension. And finally, we have a circle. I'll repeat once more. Whenever they give you a circle, ellipse, asteroid, hypocycloid, etc., changing the equation into parametric form will be an advantage for you. So let's begin with changing into parametric form. That is, x is equal to 2 cos t and y is equal to 2 sin t and z is equal to 0. So dx will be, tell me what is dx? Yeah, minus 2 sin t dt. And what about dy? 2 cos t dt. And dz will be equal to 0. And one more very important thing, t varies from 0 to 2 pi. Now I'm not going to explain how this comes. Okay, so what do we need next? F dot dr. And you can write the necessary steps, but I'm going to write that f dot dr directly. But don't do that for your exam. There will be only one question for exam, so try to explain properly. So f dot dr is going to be 2x minus y plus 2z times dx plus x plus y minus z dy plus 3x minus 2y minus 5z dz. Because this time I took r to be xi plus yj plus zk, so that dr ended up with dxi dyj plus dz. But there are some good news. What is z equal to? Z is equal to 0. So dz is equal to 0. So this whole term is going to vanish. This whole term is going to become 0. And this will disappear as well as this. So finally, our f dot dr is going to be 2x minus y times dx plus x plus y times dy. That's it. Now we are ready for integration. So the work done, because they asked work done, is nothing but integral over the given path f dot dr. And that will be integral. It's a circle. So t is equal to 0 to 2 pi. And we have to parameterize this function. So that will be, we have x is equal to 2 cos t. So 2 into 2, that gives me 4 cos t minus 2 sin t times the differential, that is minus 2 sin t dt, plus x is 2 cos t plus 2 sin t times 2 cos t dt. And now I have to use the distributive property for multiplication. I'll distribute everything, simplify. So t equal to 0 to 2 pi. This is going to become minus 8 sin t cos t plus 4 sin square t. And this dt we will write at the end, plus 4 cos square t plus 4 sin t cos t, and at the end dt, because this dt will come as a common factor. Now what do you think about this? What is sin square theta plus cos square theta? Yeah, that's equal to 1. So 4 will come common, and we get 4. I'll write this part first, and then what about this? What is minus 8 apple plus 4 apples? Yeah, of course, minus 4 apples. So I hope you're okay with this part. That's going to give me minus 4 sin t cos t, and at the end our dt. Now we are almost ready for the integration. T equal to 0 to 2 pi. We need one formula from your basic level trigonometry. I want the formula for sine 2t. Okay, that is 2 sine t cos t. Isn't it? So 2 sine t cos t is nothing but sine 2t. So I'm going to write this as, I'm going to divide by 2 and multiply by 2. So I get 2 and then sine 2t. Okay, so we are ready for integration and we get 4. It's a constant with respect to t. So we get 4 into t minus, what is integrals of sine? Yeah, minus cos. So we get plus 2 cos 2t, the whole divided by 2. Within the limits, t is equal to 0 to 2 pi. Now we plug in the upper limit for t. So we will get 4 into 2, that is 8 pi, plus cos 4 pi, that is 1, minus of, when we plug in t equal to 0, the first term vanishes and the second term becomes 1. And these two will get cancelled, and that's it. The answer is 8 pi. Now let's move on to the next question. Okay, this question is from 2070 and it's of the same type, and I think since it's of the same type, you should give it a try. So I'll write the parametric form. It's the same thing which we did. So the parametric form is x is equal to 3 cos t, y is equal to 3 sin t, and z equal to 0. And then the differentials will be minus 3 sin t dt, and dy is equal to 3 cos t dt, and dz equal to 0. And I'll tell you the final answer. The final answer is equal to 18 pi. Try it. Don't feel lazy to practice these things. Don't feel that it's a similar question so you'll be able to do it in the exam without practice. So make sure you practice and check whether you're getting the answer 18 pi. And if you need any help, you can chat to me directly from our website, or you can email me your doubts. Okay, let's try a slightly different question now. Okay, till now we had been doing problems from the two-dimensional space. Now this is in the 3-dimension, because look at the points. Okay, so the same story, find the work done. So what is work done? Integral over the given path, and here the given path is a straight line segment, and that is from this point to this point. Okay, so work done is nothing but integral over c f dot dr. The first thing we have to do is we have to find the path, and the path is a line. Okay, I hope you remember this formula from your 3-dimension. Look at this. Suppose they give you 2 points. Suppose they give you 2 points in 3-dimension. And remember, to draw a line, you need a minimum of 2 points. But 2 points are enough. If you have more points, okay, that's good. But the minimum requirement is 2 points. So if you're given 2 points in the 3-dimensional plane, then the equation of that line will be x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1 is equal to t. This is called the symmetric form. You might have learned in your second semester. Anyway, let's apply this formula and find C. And what is C? The path. And what's the path here? It's a line segment joining 1, 1, 1 and 3, 3, 2. So the formula is x minus 1 by 3 minus 1 is equal to y minus 1 by again 3 minus 1, and that's equal to z minus 1 by 2 minus 1 is equal to t. Now let's convert this into the parametric form. So I will use this equal to this. So I'm going to get x is equal to 2t plus 1. And when I equate this and this, I get y is equal to 2t plus 1. And finally, z equal to t plus 1. Okay, so we are ready with the parameters. Now we need the differentials. So I'll write the differentials over here. Dx is equal to 2 dt and dy is the same thing, 2 dt, and dz is equal to dt. Now we need one very important thing, which in circle was very easy. In circle, I use the limits 0 to 2 pi. Even if it is an ellipse or a hypocycloid or an asteroid, it's going to be 0 to 2 pi. And in this case, we have to find the value of t. So that's very easy. You can use x or y or z for the trick. Anyway, for the time being, I am going to use x. So x is equal to 2t plus 1. That means 2t will be x minus 1 and t will be equal to x minus 1 by 2. Now, the limit of x varies from 1 to 3. So when x is equal to 1, t will be equal to 1 minus 1, that is going to give me 0. And if x is equal to 3, t will be equal to 3 minus 1, 2 by 2, 1. That means our t is going to vary from 0 to 1. You can try the same thing with y or z. So look at this, z is equal to t plus 1, so t equal to z minus 1. And this z varies from 1 to 2. So when z equal to 1, t will be equal to 1 minus 1, 0. And when z equal to 2, t will be 2 minus 1, that is 1. So look, we got the same answer. Okay, now let's start with our integration. So we have to find the work done, and work done is nothing but integral over c f dot dr, and that will be integral over c. Now I'm going to write f dot dr. I'm going to write directly, but in your exam it's better to show the steps. So that's going to be yz into dx plus zx into dy plus xy into dz. So now let's parameterize it. Let's plug in all these values. So y and z. So it's going to be t equal to 0 to 1 and 2t plus 1 and t plus 1 and finally 2 dt. So I'll plug in this 2 over here plus z into x. Okay, that's going to give me the same thing. So 2 into 2t plus 1 into t plus 1 plus x into y, and that will be 2t plus 1 the whole square, and dz is just dt. So I'll write the dt. So integral t equal to 0 to 1, this is going to get 4 because a plus a is equal to 2a. So you're just going to get the double of this part. And let's simplify this, distribute this. So 2t square plus 2t plus t, that will be 3t plus 1 plus 4t square plus 4t plus 1 dt. And you can simplify this. It's going to be integral t equal to 0 to 1. So you get 8 plus 4, that's going to be 12 t square, plus you're going to get 12 plus 4, that will be 16t, and finally 4 plus 1, 5. Okay, so we are ready for integration. So 12 into t cube by 3 plus 16 into t square by 2 plus 5 into t within the limits t equal to 0 to 1. Now let's plug in the values. So you're going to get, when you put the lower limit, it's going to be 0. So we have to put only that upper part. So that will be 4 plus 8 plus 5. 12 plus 5, that is equal to 17. Now let's try one more question. Okay, it's a question back from 2016-9, but this question is very important because it's not a circle or an ellipse or a line. It's actually a combination of two different curves. So you should understand how to proceed with such questions. So let's change this into a graph. I hope you know what is y square equal to x. Y square equal to x, that means one variable has square and the other variable is linear. That means it's a parabola. And if you see y square, that graph will be symmetric about the x-axis. And similarly, x square equal to y. Look at this. It's of degree 2 and degree 1. That means it's a parabola. And we are going to get something like this. And we are doing line integral. In the first video itself, I told you, even though we use the name line integral, we will be integrating along a curve. So we have to fix the limits. So that is exactly what we are going to do first. We will solve and find the points of intersection. So y square equal to x and x square equal to y. So if you read this from right to left, we get y equal to x square. And I'm going to plug in this value of y here. So what is y? X square. So I'm going to get x square the whole square equal to x. That means x to the power 4 minus x equal to 0, or x times x cube minus 1 will be equal to 0, and that means x equal to 0 or x cube minus 1 equal to 0, and that of course implies x equal to 0 or x equal to 1. Now let's plug in all these values here. When x equal to 0, we get y equal to 0 square, and when x equal to 1, we get y equal to 1. And from the picture itself, it's clear that the points of intersection are 0, 0 and 1, 1. Anyway, this is obvious. Now let's make it clear. So we have our x-axis and y-axis, and our parabola y square equal to x, and the second one, that is x square equal to y. And we just found that this point is 1, 1. That means this is x is equal to 1, and this is y is equal to 1, and of course this is our origin. And remember, the path of integration will be always taken counterclockwise, anti-clockwise. So let's give some name, O, and somewhere here A, B, C. So the path of integration is O, A, B, C, O. Okay, so it is split into two parts. The first one is O, A, B, plus the second one BCO. In the first path, we move along the green parabola, and the green parabola is y is equal to x square. So dy is equal to 2x dx. I'm just getting ready so that we can substitute in that f dot dr. And now something extra important, the limits. Look at this, we move along the, I think you can see the white dots, we move along the parabola like this. And you have to focus on the axis. As we move along the parabola, I'll strongly recommend you just look at the axis so that you're able to find the limits of x. And that tells me x is varying from 0 to 1. I'll repeat once more. If I am here, the projection will be at this point. And if I am here, the projection will be at this point. And if you want the limits of y, you do the same thing, but you do the projection on the y-axis. So if I am at this point, it's like y varying from 0 to 1. So if you want, you can write the limits of y 0 to 1. Now let's take a look at the second one, BCO, the green parabola. The equation to the green parabola is y square equal to x. Okay, and in the green parabola, we have to move in this direction. So if I am here, the projection is over here, over here, over here. So be very careful. The limits of x vary from 1 to 0. This is something very, very, very important. I'll repeat. We are moving in counterclockwise direction. So from here we reached B. Now in BCO, so we begin at this point. So the projection starts from 1 to 0. Okay, now that's it. The rest is simple integration. Okay, now we have to find integral over C f dot dr. And that is equal to integral. C is actually OABCO. I shouldn't have used this C. Anyway, let's continue with this. So that is OAB plus BCO. So OAB plus integral BCO. And f dot dr is x minus y dx plus x plus y dy. And the same thing, x minus y dx plus x plus y dy. Now I told you the logic for such integration in lesson number 1. You can convert everything with dx into x and the quantities with dy into y, or you can do vice versa. It's completely up to you. I'm going to write x is equal to 0 to 1. And that means I'm going to convert everything into x. So x minus, look at this, I already written all the details over here. So y is x square and there is dx here plus x square, and what is dy? Dy is 2x dx plus integral. If I want, I can convert everything into x or y, or half into x and half into y. But I feel converting into y is more going to give me more advantage. So look at this. When I move from here to here in this path, I have to focus on the y-axis. We start from y equal to 1 and end up with 0. So the limits are y equal to 1 to 0 and x is going to become, look at this, the blue parabola is x is equal to y square. So I have to put y square minus y. So x is equal to y square means dx is equal to 2y dy. So 2y dy plus again x, that is y square plus y into dy. And now it's up to you, you can integrate by yourself. And I'll write the final answer. You're going to get 2 by 3. Now I'm going to wind up this video right here, but I'll be back. And in the next video, we'll learn something very important called the scalar potential. And we'll do 1 or 2 problems based on this. And that will be lesson number 3. And in lesson 4, we will learn a very important theorem that is called the Green's theorem. So till then, bye.